Next on deck, we've got Samantha Lavender from Pixalytics.
So I'm a bit different, I think, to everyone who's talked before, because I've not been part of the STAC development community. So I'm a co-founder of Pixalytics, and I would describe myself as a scientific code developer rather than a software engineer or official developer. And I really develop code because it's something I enjoy. And I've done it since a PhD student, and it's partly why I own a company, really, because I think if I was at the stage of my career where I'm now in a large company, I wouldn't be allowed to code develop. So recently, Pixalytics has joined OGC, and we came in through an EO activity, and then took part in the Testbed 17 activity. And this is one of the latest innovation activities looking at supporting geospatial software architectures, processing and data handling. And the activity, I say we in the broader sense because it was me, got involved with was the API task, which was looking at rapid prototyping, design, development and testing of the API tools. And so as well as not being particularly familiar with STAC, I mean, I'd heard of it through the Earth observation community, but I also hadn't really been involved in the development of the OGC standards or specifically API activities either. And so within the Testbed 17, there were 3 roles. There was the data backend, the actual developer for the server for the hosting the data and serving it out, and then the client interface. So I volunteered as the back end, really, because that was what looked closest to my existing knowledge. And on my slide, you've got the engineering report for the whole activity, so you can go and browse that as well. And there was a user survey looking at what developers are interested in terms of getting to know code as well. So for myself, I took a data set I developed as part of an international project where I derived a land cover classification for Kenya, looking at sustainable sand extraction. And that data was originally stored in GeoTIFFs, and I converted it to COGS and netcdf files. I think I did the COGS correctly, but I will now go and test it with the tester code that was mentioned earlier today. The reason for the netcdfs is we were looking at individual time steps as well as a time series. So we held the time series within a netcdf with the OGC EDR, environmental data record, as an approach, and I deployed those COGS and netcdfs to an Amazon S3 bucket, and then I built both STAC and record catalogs for them that I deployed to the same S3 bucket. Plus, I also ingested in Amazon OpenSearch, which was previously called Elasticsearch. And I have to say that what was really most useful as someone coming new to both the STAC and OGC standards is really code repositories and open code. Because as a developer, I find it easier to read code than documentation. So I ended up using PyStack and PyGeoMeta in order to build the backend catalogs. And I used Elasticsearch and Elasticsearch Loader to actually deploy to Amazon OpenSearch. So you have to be a bit careful with that second one because of this name change is also represented really in the open GitHub repositories in the latest versions of the GitHub repositories don't support Amazon because there has been a bit of a I don't know if falling out is the right word between Amazon and Elasticsearch. You have to be a bit careful there. And so the STAC and the records catalogs are very similar. I wouldn't say at the moment I know which you would necessarily choose one over the other specifically, but you can look at the code repository I've created, and I will carry on doing development and testing on this. So thank you very much for listening. I think I've gone over my 5 minutes, so I will try and
Right on time.
stop now.
Beautiful. Thank you so much.
Go on.